Teegarden B and C, the closest habitable worlds to Earth. In the vastness of the universe, there are all kinds of stars with exoplanets, but you don't have to go far to find extraordinary places. That is the case of the star Teegarden, which is only 12 light-years from our planet and hosts 2 confirmed exoplanets. These exoplanets are not only in the habitable zone of their star, but also resemble our planet. One of them could even have an ocean. What else do we know about these exoplanets? Do they have the conditions to house living beings? Stay with us to find out. Teegarden is a red dwarf star located in the constellation of Aries, visible from the Northern Hemisphere. Despite its cosmic closeness, only 12.5 light-years away, it was discovered only in 2003 by a team led by astronomer Bonnard Teegarden, whose surname gave this celestial object its name. Teegarden is an M7.0V type dwarf star, among the universe's smallest, coolest, and longest-lived. Its surface temperature is around 2900 Kelvin, much lower than the Sun, which reaches 5778 Kelvin. It has only 9% of the Sun's mass, and its diameter is around 116,000 kilometers, barely 14% of the Sun's diameter. This combination of size and temperature makes it an extremely dim star. Its luminosity is only 0.00073 times that of the Sun. What's most intriguing is that it wasn't discovered observationally with a telescope, but rather through a review of archived data. Teegarden and his team at NASA's Goddard Space Flight Center analyzed records from the Near-Earth Asteroid Tracking (NEAT) satellite, and after studying its proper motion, more than 5 arcseconds per year, one of the highest known, realized that they were looking at an unknown and very close star. As a red dwarf, Teegarden belongs to the category of the most abundant cosmic objects in the galaxy. It is estimated that approximately 75% of the stars in the Milky Way are of this type. Their lifespans can exceed 100 billion years. To put this into perspective, the lifespan of stars like the Sun is only 10 billion years. This makes red dwarfs ideal candidates for hosting stable planetary systems for very long periods. Its low luminosity means that any planet will have to orbit the star extremely close to be within the habitable zone and be able to have the temperature needed for water to remain in a liquid state. And it is precisely in that area, in an orbit very close to the star, that astronomers found 2 small exoplanets that have impressive characteristics. Teegarden B, a world in the habitable zone. The first of these worlds is Teegarden B. It was discovered in June 2019 by an international team from the Carmenes project, a high-precision spectrograph installed at the Calar Alto Observatory in Spain. Teegarden B is one of the most promising exoplanets we know of in terms of habitability. This world was identified using the radical velocity technique, which measures the small oscillations of a star caused by the gravity of a planet orbiting it. Teegarden B is a rocky planet with an estimated minimum mass of 1.05 times the mass of Earth. This suggests that it could have a similar composition to our planet, with a metallic core and silicate crust. It is located at approximately 0.0252 astronomical units, or AU, from its star, or about 3.77 million kilometers. For comparison, Mercury orbits the Sun at 0.39 AU, indicating that Teegarden B is much closer to its star than Mercury is to the Sun. But this doesn't mean that Teegarden B is a fiery planet. Let's remember that Teegarden is a much cooler and dimmer star than the Sun, so its habitable zone is also much closer. The planet completes one revolution around the star every 4.91 Earth days, implying an extremely short year. Despite this speed, current models suggest that Teegarden B lies within its star's habitable zone, where temperature conditions could allow liquid water to exist, provided an atmosphere capable of regulating the climate. No atmospheric components have been directly detected, but some speculative atmospheric models, based on the distance from the star and its spectral type, indicate that if Teegarden B has a dense atmosphere similar to Earth's, it could maintain temperatures in the range of 0 to 50 degrees Celsius. However, in the absence of an atmosphere, Its surface temperature could be very low, ranging between -30 and -50 degrees Celsius due to the low stellar irradiation. Another relevant aspect is the possibility of tidal coupling. Given how close it is to its star, it is likely that Teegarden B is tidally locked, always showing the same face towards Teegarden. This would give rise to a permanently illuminated daytime hemisphere and another in perpetual darkness, with an intermediate twilight zone where life could exist. Hey guys, before moving on, I want to let you know that I launched our membership. So if you want access to our content in advance and other advantages, become a member by clicking the join button. With the team, we're working to excite you as much as possible through perks. I'll see you there. Teegarden C, a cold planet, but with potential. The second exoplanet found is Teegarden C. Although it is located on the same host star, its orbit is slightly further away, and with it arise new implications for its possible habitability and physical characteristics. Teegarden C has an estimated minimum mass of 1.11 times that of Earth, which also places it in the terrestrial or rocky planet category. It orbits at a distance of approximately 0.0443 astronomical units, equivalent to about 6.63 million kilometers from its star. It completes one revolution around Teegarden every 11.4 Earth days, making it a planet with a very short but longer year than its sibling, Teegarden B. Regarding relative position, Teegarden C sits right at the outer edge of the star's habitability zone. This means that while it receives less radiation than Teegarden B, it could still maintain temperatures compatible with liquid water under certain atmospheric conditions. Some models suggest that if Teegarden C possesses an atmosphere dense with greenhouse gases such as carbon dioxide, it could trap enough heat to maintain a temperate surface, with possible regions with liquid water, especially near the planet's equator. However, without a significant atmosphere, calculations indicate that its effective surface temperature would be around -47 degrees Celsius, making it a cold world, probably covered in ice or with a frozen surface over much of the planet. This does not exclude the possibility of life. Still, it would make it more complex, perhaps restricted to underground or subglacial areas, as speculated in icy moons of the solar system such as Europa or Enceladus. Teegarden C could also be tidally coupled like its brother Teegarden B. Still, Teegarden C is a colder world, possibly less hospitable on the surface, but perhaps more stable in orbital terms and with greater protection from stellar radiation. Could some cold, hardy life form be there, hidden under the ice? Could Teegarden B and C be habitable? When astronomers discover an exoplanet, one of the first questions arises: could it be habitable? But answering that is not as simple as it seems. The concept of habitability is not just about being in the habitable zone, but about a complex combination of factors such as atmospheric pressure, chemical composition, surface temperature, radiation protection, and orbital stability. Teegarden B and Teegarden C are located in or near their star's habitable zone, but the differences between them could be crucial for the development of life. Teegarden B, being closer to the star, receives greater irradiation. Its estimated surface temperature, in the case of an atmosphere similar to Earth's, could range between 0 and 50 degrees Celsius, which is remarkably compatible with life as we know it. In addition, with a mass so similar to Earth, it is reasonable to assume that it could have a similar surface gravity, which would help retain a dense and stable atmosphere. If that atmosphere contains gases such as nitrogen, oxygen, water vapor, or carbon dioxide, we could look at a truly habitable planet. The big obstacle is that we don't have direct evidence of its atmosphere, nor know if it has a magnetic field to protect its surface from stellar radiation. Red dwarfs like Teegarden, while very long-lived, are known for their violent stellar eruptions, especially during their first billion years. These flares can rip through the atmosphere if the planets don't have a magnetic shield. However, recent studies suggest that Teegarden is a tranquil star, which improves the picture. Teegarden's location on the habitable zone's outer edge implies less irradiation and lower temperatures. But if it has a powerful greenhouse atmosphere, it could retain enough heat to maintain liquid oceans beneath a layer of ice. similar to what is speculated about Europa, a moon of Jupiter. Subsurface habitability is an intriguing possibility in astrobiology, and Teegarden C could be an excellent candidate for this type of environment. Therefore, both planets offer possible scenarios for life. Teegarden B would better suit surface life forms, while Teegarden C could hide life under the ice. There is no definitive proof yet, but speculation allows us to dream of one or even two habitable worlds just 12.5 light-years away. An unattainable world, but full of hope. In such a vast and ancient universe, finding a nearby star system that might host worlds similar to ours is fascinating and deeply inspiring. Teegarden B and C, located just 12.5 light-years from Earth, are like silent beacons in the cosmic ocean. Although we have no way to visit them today, their existence reminds us that life might not be confined to just one corner of the universe. From a technological perspective, reaching these worlds remains a distant dream. Even the fastest probes created by humans, such as Voyager 1, would take more than 100,000 years to reach a star system at that distance, traveling at its current speed of 17 kilometers per second. Futuristic projects like Breakthrough Starshot, which aspire to send laser-powered microbes at relativistic speeds, are still in conceptual phases and only point to closer systems like Alpha Centauri. However, although unattainable for now, Teegarden B and C play a fundamental role. They force us to imagine. They make us think about the engineering, biology, and physics needed to achieve them someday. They represent a long-term goal for humanity. If we ever develop technologies capable of interstellar travel, whether through fusion propulsion, warp drives, or as yet unconceived means, these worlds will be at the top of our list of destinations. Because of their proximity, their potential habitability, and everything they could teach us about the formation of planets and the possibility of life beyond Earth. In addition, their remote study using advanced telescopes such as the James Webb Space Telescope or its successors could reveal chemical indications in their atmospheres in the coming years. Oxygen, methane, water vapor, or carbon dioxide. Biomarkers that would bring us one step closer to answering the fundamental question: are we alone in the universe? Teegarden B and C are still there, silently revolving around a faint star barely noticeable from Earth. They are distant worlds, yes, but they also promise discovery, exploration, and perhaps one day, a home for humanity.